I'm a big data developer at Onwello. I will tell you today how to build stream processing pipelines with Apache Flink. Okay, let's start. So why stream processing? Why streaming? At last PyData meetup, Michał Jaślan from Onwello talked about Apache Hawk. Apache Hawk is a SQL on a Hadoop engine that is part of our analytic platform. We use Hawk to process big data in a SQL way. But some of our clients need to process the data faster. They realize that that approach is not enough. And we have to find some stream processing engine to meet our needs and meet our clients' requirements. So that stream processor should process data very fast with low latency. So, for example, we need to process 10,000 of events or 100,000 of events per second with latency below 400 milliseconds end-to-end processing. We have to, this stream processor should process data in exactly one manner and should have support for out-of-order events. Yes. So why Flink? So why we Flink is a good choice for that. Flink is a unified batch and stream processing engine. It has high performance and low latency. It has support for event time and out-of-order events. In Flink we have 4 time definition. We can process data in ingestion time. This is time of event when the event arrives to the Flink. We can process data with processing time. It is simple time of local machine. And we can process data with event time. Event time is time extract directly from the processing events. Flink can process data in exactly one semantics for stateful computation, and Flink processes data in continuous streaming model with back pressure, which really works. And Flink has highly flexible streaming windows. It has support for session windows. It has support for time blink windows and for sliding windows. It has great streaming windows support. How Flink stack looks like. So as you can see, you can deploy Flink on single JVM without any cluster or Hadoop. It can run also in clusters and yarn management cluster. The core of Flink stack is a unified runtime. At the top of this runtime we have dataset API for batch processing, a data stream API for stream processing. Dataset API comes with Flink ML machine learning library with Jelly graph processing library and standard table relational library. And then the data stream API comes with CEP, it's complex event processing library, which we show later on demo, and standard table relational API library. So to show you Flink power, we made up some demo, some user case to show Flink capabilities. So in our made up demo, we try to find ATMs that might be used by skimmers to do some withdrawals. By skimmer, I mean people who clone your credit card, who steal your credit card credentials and later try to withdraw some cash from ATMs. We have some assumptions. We will be processed 8 input data called ATM event. We'll have ATM ID, client ID, and some amount of withdrawal. We assume that every client has his own safe withdrawal amount threshold. So every event with amount below the threshold will be considered as safe, and that safe event shouldn't generate any warnings or alerts. We assume that if we get 2 suspicious withdrawals at the same ATM within 40 seconds, it should generate ATM warnings. And we assume that two ATM warnings within 40 seconds should generate ATM alert and alert some in a bank or send some message to client. Okay. What would be look like from high-level architecture? At input we have Kafka with messages from ATMs. In Redis we have memory thresholds for each client, so we have to do fast in-memory lookups to Redis and enrich the input stream. And with that enriched input stream we do some CAP processing to do alarming and alerting. And we use some windowing to calculate some KPIs. Okay, how is it look like from application perspective? So we have one input event stream and 3 stream transformations. And the output is contains of 4 streams. That first transformation, it will be a simple lookup to the Redis and enrich event stream. Second transformation, it will be CP processing transformation that from our enriched event stream we generate some warnings, and the last transformation will be also CP event transformation. From warning stream we generate other streams. And to do some CP stream transformation we need basically 3 steps. First of them is that we have generate some pattern. In next step we have to apply that pattern on event stream, and at last step we have to select these events that match to our pattern and generate for them warning stream or alarm stream. On this application we have access to all these 4 streams, so we can do some transformation or analytics on it. So we show you also some windowing at warning stream, and we do some window KPIs. So we simply count warnings per ATMs in some time window. Okay, I will show you some code. Co?
Coś zakręcił, to nie jest z tej
Okay, can you hear me? No, not really.
Ktoś zakręcił na amen.
Okay, so okay. Okay, to do some code, at first we need map our event types in Java classes. Okay, I have some code, but I think it's not really interesting for you, so I will go to directly to flow programming. So what the Flink application look like? This is a small change. I don't have here a Kafka consumer. I wrote directly data from ATM event source to Flink, so it's some kind of Kafka bypass. Okay, at this is input stream definition from Flink. So I get some source which generate ATM events. This is the first stream transformation. So this is lookup to Redis. I wrote some flat map implementation that look into Redis and doing something like left join and get users thresholds. And this is the second stream transformation in these 3 steps. So at first step we generate some pattern. Yeah, our pattern was to ATM events with amount above threshold within 40 seconds. So it looks like that. Our second step is apply that pattern that we write above to event stream. And in third step we select the data from pattern stream and generate ATM warnings. We do the same to third transformation, so we do the same to warning pattern, and at this pattern we expected 2 warnings within 40 seconds. Okay. We have also a part that using windowing and counting our warnings per ATM, and it looks like that. So it's pretty simple. It's straightforward. Okay, and that's all stream flow definition in Flink. We have here print warnings and alerts for console, and this is a part that writes our window, our KPI results to Elasticsearch, and I show you later this in Kibana. So let's try fire up. Okay, so as you can see, it's connecting to Redis, but right now, and it's printing our warnings and alarms directly to our console. And our KPI window, our KPI is writing to our KPI stream is writing to Elasticsearch, so we can look at Kibana and okay, so as you can see, stream processing is working, and the fact that we have thresholds in Redis, we can use that fact to dynamically update the thresholds, yes, and impact on our stream processing. So now we can try to modify Redis thresholds. So we can set very low thresholds, so we get a very high number of warning and alerts. We should get it. Yes, as you see, number of warnings increases. Can set threshold very high, so we should get any warnings at all. Yes, as you can see, the number of warnings drops, and this is a tumbling window, so it's last 20 or 40 seconds. Okay, and we can back to default value. Okay.
Could you magnify it, perhaps?
Yeah, we can magnify. Yes, it's a Kibana, so you can do whatever you want with this data. Okay. When I apply this pipeline in my home cluster, I get some cool results. I can process up to 50,000 events per second with very low end-to-end latency. So most of the data have latency below 50 milliseconds. At end-to-end processing. So when the event comes into pipeline, and this was last event in pattern, and that event should generate alarm, and then that alarm shows up on the end of pipeline at about 100 milliseconds later. So I think it's a great performance for that hardware, as you can see. What for we use Flink? We use Flink for real-time analytics. Yeah, we can enable some insights as soon as data arrives. Yes, we use Flink to fraud and anomaly detection, and for real-time personalization. Yeah. We use Flink to show some recommendations or discount for clients in real time. What else can be used? I think Flink is a great tool to infrastructure monitoring for IoT. streaming ETL, and even more. Who is using Flink? Flink is used by Alibaba. They use Flink to continuously rebuild their search indexes at massive scale. I think they had a cluster with 2,000 Flink nodes. Zalando use Flink to monitoring their business process in real time. And King is a game developer, Candy Crush or something like that. They use Flink to do some real-time analytics at events from games. And I know that Ericsson use Flink too. They use Flink to detect anomalies in their infrastructure. And we are planning to use Flink. Use Flink to some kind of real-time continuous learning models. And I think Flink is a great tool to fast data processing. You don't need very powerful hardware to run Flink in very fast manner. So I think it's a great tool to fast data processing. And that's all for today. Maybe we have some questions.
Questions regarding Flink or the solution, maybe? One question?
Could you give some examples of machine learning algorithms which are available in this Flink?
Okay, I don't use the machine learning library is in Flink batch API, which I don't use, but I saw that they have some standards machine learning algorithms like k-means or some regressions. You have to look at the Flink page to check what we have.